Have you ever wondered how a rocket, weighing thousands of pounds, defies gravity and reaches outer space? Well, let's delve into the fascinating world of rocket science together. The fundamental principle at play here is Newton's third law of motion, which tells us that for every action, there's an equal and opposite reaction. In the case of a rocket, the action is the expulsion of gas out of its engines. The reaction? The rocket moves in the opposite direction, upwards, into the sky. Now, let's talk about thrust and velocity. Thrust is the force that propels the rocket upwards, overcoming Earth's gravity, while velocity is the speed at which it moves. Together, they're the dynamic duo that launches a spacecraft into orbit. A rocket is made up of multiple components, each with its unique role in this cosmic ballet. From the propellant that fuels the engines to the guidance system that navigates the journey, every piece works in harmony to defy gravity and reach the stars. As complex as it might sound, the magic of rocket science is all about pushing against Earth's gravity and moving forward. Once a spacecraft is in space, how does it know where to go and how to get there? That's a question many of us have pondered. The secret lies in celestial navigation, a time-honored method that uses the positions of stars and other celestial bodies as reference points. Astronauts use star charts, sophisticated instruments, and advanced computer systems to plot their course through the cosmos. They constantly track their position relative to these celestial markers to ensure they're on the right path. But it's not just about knowing where you are, it's also about knowing where you're going. This is where the challenges of long-duration space travel come into play. Astronauts must calculate trajectories and velocities with pinpoint precision, accounting for factors like gravitational pull and cosmic drift. Despite the complexities, astronauts are equipped with the tools and knowledge to navigate these vast cosmic distances accurately. Navigating the cosmos might seem like a daunting task, but with the right tools and knowledge, it's a journey filled with discovery. How far have we come in our quest to explore the universe, you might ask? Well, let's take a moment to reflect on the monumental achievements that have defined our journey into the cosmos. Our first significant leap occurred in 1969, when Neil Armstrong, representing the Apollo 11 mission, took one small step for man, one giant leap for mankind, becoming the first human to set foot on the moon. This iconic lunar landing forever changed our perspective of what's possible. Fast forward to 1971, and we find ourselves on Mars, albeit remotely. The Mars 2 mission by the Soviet Union was the first to reach the red planet, dropping a descent module onto its surface. Though it didn't survive the impact, it marked the beginning of our fascination with Mars. The late 20th century brought us the Voyager missions, launching in 1977. These two unmanned spacecraft are still traveling, having journeyed beyond our solar system and into interstellar space, carrying messages from Earth for any extraterrestrial life that may exist. Fast forward again to the 21st century, and we are back on Mars, this time with rovers like Spirit, Opportunity, and Curiosity. These robotic explorers have provided us with invaluable data about the Martian surface, climate, and potential for life. In the grand scheme of things, these milestones are just the beginning. The cosmos is vast, and our journey of exploration is ongoing. These milestones in space exploration are a testament to human curiosity and our unending desire to reach for the stars. What does the future hold for space exploration? As we venture further into the cosmos, our ambitions are as boundless as the universe itself. Upcoming missions are not only focused on exploration, but also on the potential utilization of space resources. Imagine asteroid mining, an endeavor that could provide us with untapped reserves of precious metals and other materials. These resources could fuel our economies, creating a new age of prosperity. But the future is not just about extracting resources, it's also about expanding our horizons, literally. Colonization of distant planets is no longer a far-fetched concept, but a tangible goal. Mars, with its similarities to Earth, is a prime candidate. We're already laying the groundwork, with rovers like Perseverance paving the way for human exploration. Interstellar travel, once a staple of science fiction, is also inching closer to reality. Breakthroughs in propulsion technology could one day take us to exoplanets in distant star systems, opening up a universe of possibilities for discovery and exploration. And who knows what we might find out there? New forms of life, alien civilizations, or perhaps answers to some of our oldest questions about the universe. The future of space travel is as boundless as the cosmos itself, filled with endless opportunities for exploration, discovery, and perhaps even new homes for humanity. The cosmos awaits us, and we're just getting started.